है, उन्हें पता है ऐसी चार्ट करिए वो करिए।
मेरा माइक ऑन है। Alright. So zero order reaction, first order reaction, you guys are aware of, you're clear. So that's all depending on like what is the dependency of the concentration of the reactant for that particular rate of a reaction. Okay. Half life ka meaning hai the time that it takes for the concentration of that substance to fall to half of its initial value. Okay. Have you guys done radioactivity in physics?
Yes, ma'am.
So like half-life you guys must be familiar with in that context, right?
Yes, ma'am.
Yes, so it means the exact same thing, except those are nuclear reactions. Here we will be dealing with chemical reactions. That's it. And then we've got pseudo first order reactions. Again, pseudo matlab false. So basically these are not first order reactions, but they behave like first order reactions in certain conditions. So most commonly this happens when one of the reactants is in excess. कि इतना ज़्यादा है reactant that it like the change in the concentration of that particular reactant doesn't really matter because there's so much of it. Anyway, so we'll get into more detail of all of these things. All right, so coming to the integrated rate equation for a zero order reaction. Let's derive what it is and we'll look at the analysis. Okay. Oh, awesome. Arya has joined in, Ritvik also has joined in. Cool. Okay, so what do you mean by a zero order reaction? Uske liye, how do I express the rate? So rate will be
equal. Rate will be expressed in moles per liters per second.
Units hai wo, theek hai. What should I write in the equation itself, zero order ke liye?
Ma'am, it should be proportional to K.
Yes. Proportional nahi, rate is equal to K. So Jasmine says which has zero power, matlab it is not dependent on any reactant ka concentration at all. So if the equation is R gives product, reactant gives products, it is independent of the concentration of the reactant, power zero, which means that rate will be equal to K. But rate is basically change in the decrease in the concentration of reactants, right? With respect to time. So if we take instantaneous change, so dr by dt will be equal to K. So if we have to make sense of it, let's integrate it. So integrate karne ke liye all the same variables to one side. So dr will be equal to K into dt. So if I integrate it on both sides, क्या आएगा मुझे? Integral of dr will be?
Ma'am, R is equal to K square.
R. And integral of k dt will be?
K square by 2.
Since K is a constant, it will come out of the integration.
Be careful. यहाँ पे dt है. So we're looking at change in time. So unless you have a variable of time, k is a constant. So there's not going to be any change here. So Ritvik, if it was a case where it's integral k dk, tabhi this is gonna change into k square dk.
Yes, ma'am.
Yeah. Yes. So Aryan, as Aryan said, so k will come out of this thing. It's gonna be constant, and integral of dt will be
T.
T. Okay. And is this my final expression? Khatam ho gaya? This is my equation for a zero order chemical reaction.
Yes, ma'am. Looks like it.
You guys have done what do you call it, integrations pehle, right? Like physics में भी आया होगा the basic
Yes, ma'am.
this level का integration. So every time you integrate any differential equation, will you end it with
Oh
this?
yeah, plus 3.
Don't forget about it. Plus constant. Okay. अभी इस constant का value कैसे find out करें? All right. So at the beginning of the equation, like when t equal to 0, let R, so at t equal to 0, what can you say about the concentration of the reactant?
It will be maximum. Or we can take it as 1 if that's
No,
that's fine.
you can take 1 because concentration of reactant कोई भी हो सकता है ना, so that is one thing that you're controlling. I can take 1.5 m of HCl also, or I can take 10 ml of 3m HCl also. कुछ भी हो सकता है. So
we'll take maximum only then.
Yeah, so let R equal to R naught, which is the initial concentration of the reactants. अभी तक कोई change नहीं हुआ. So will R naught, like, is this a constant or is it going to keep changing? The value of R
It will
naught.
keep decreasing.
No, concentration
as
of
the reaction goes on.
So concentration of R will keep decreasing, but R naught is going to be the same. मतलब
Yes, ma'am.
initially जितना लिया उतना ही होगा, right? So substituting at t equal to 0, you get concentration of R equal to K into 0 plus C, R naught, because we're taking it at t equal to 0, which means that basically the constant is going to be equal to R naught. So basically for a first order, for a zero order chemical equation, for a zero order reaction, the rate equation, the integrated rate law is going to be so concentration of R is equal to Kt plus R naught, which is the initial concentration. Okay, now this is important. You can write down the whole derivation, but especially make note of this part. Okay. So once you're done, let me know. We'll get into analysis of this equation, what it means and how it can be used.
Yes, I'm done writing.
Done? Okay. Everyone?
Yes, no.
Okay. Cool. So if I were to, okay, so is equation mein, what are the variables?
Only time is the variable, right? Because
Only
K
time?
is the rate constant.
Yeah, K is a constant. So this is a constant. So time is a variable. What about concentration of R?
That is also a variable with respect to T.
Yeah.
Yeah,
It is.
so that's going to change with respect to T. That's why this equation. So K is a constant. Initial concentration is also a constant because initially jo liya, that is going to be an absolute value. Okay. So the only variables are time and concentration of reactant. Also, the concentration changes with respect to time. So if I were to draw a graph between concentration and time, how are they going to vary with each other? What sort of graph will I get?
It's directly proportional, so it will be a linear graph.
यहाँ पे there is one.
And plus, it's like a mx plus c thing. No?
Hang on. यहाँ पे I have made a mistake here. Can anyone figure out what that mistake is? So if I want to consider rate with respect to reactants, is this expression correct?
Now a negative sign will be there.
Yeah, I missed out on that. Yeah, so these are the little things, even if I am also not focused enough making this sort of mistakes. So you guys don't do that, huh? So negative sign रहेगा. So let me take it to RHS. यहाँ पे भी negative आएगा, which means that this is minus KT. ठीक है. So इधर भी ये minus K into 0 हो गया. Now coming to the rate equation, this is not correct. So this will be minus KT. ठीक है. हाँ. So now what will be the shape of the graph? So the variation is, Aryan, you were saying, you can continue, like how is R varying with respect to time? So R is one variable, so it's Y equal to T. So this is a constant. So mx plus c, x and y are variables. This is exactly matching this thing. So what can you say about the variation of R with respect to time? किस तरह का variation है ये? So Jasmine says y-axis will be R and x-axis will be time. Yes, this is the independent variable. The time keeps going, and this is the dependent variable. तो किस तरह का graph होगा? What is the variation going to be like?
It will be a negative slope, no?
Yeah. So first thing, variation, ये equation किस graph का equation है? So this represents negative slope, ठीक है, but is it going to be like this or like this or like this?
Straight
Like
line.
straight line. Yes. So variation is linear, and so linear graph banega in which slope will be equal to negative slope hai, so it's going to be like this. So slope, can you find what is the value of slope?
Minus K.
Yes. So Jasmine, be careful. You don't forget the minus sign here. So slope equal to minus K. Negative slope hai, decrease ho raha hai with respect to time. Okay, and the y-intercept is going to be equal to y-intercept matlab, where is it going to intersect the y-axis? So what value is this going to be? So you can like use common sense also, like logically be you can figure it out. R naught, concentration of R at T equal to 0. Initial concentration hai na? This is basically your initial concentration. Okay? All right. Now let's say you're analyzing a chemical reaction, like you are experimentally doing a chemical reaction and you wanted to find out the rate constant. Okay, so in that case, if K is the unknown value. You know how much initial reactant you've taken. Then you can measure time using a stopwatch. And then after a certain amount of time, you can figure out what the final concentration is. So for a zero order reaction, how will you find out the value of K? What will be the formula for K? So are you noting it?
Ma'am, minus of R minus R naught by T. Ma'am, your mic is off.
Thanks. I thought I'd unmuted. Okay. So minus of minus, I can also write it as R naught minus R by time. Okay. So by applying this, you can find out what is the value of K. Graph में this y-intercept is equal to R naught and ये line का slope will be equal to minus K. Okay. All right. So we'll do some example problems for zero order reaction before moving on to first order reaction. Okay. So before we do some practice problems, can you imagine where zero order reactions, like what type of reactions could be zero order? So zero order reactions may, it is the rate of reaction is independent of the concentration of the reactants. तो किस cases में ऐसे हो सकता है? Where would you usually find zero order reactions? So one case is your enzyme, like enzyme catalyzed reactions, like living organisms में जो होता है. How are enzyme catalyzed reactions zero order? So enzyme catalyzed reactions में the reactions don't take place unless and until that particular enzyme is there, right? Now, no matter how much reactant you put in, you know, as long as that enzyme is completely occupied, it doesn't matter if you increase the concentration of reactants or decrease the concentration of reactants. So it all completely depends on the availability of that enzyme. So that's why enzyme catalyzed reactions are zero order reactions. Another case, similarly, the reactions catalyzed by metal. So can you give an example of such reactions? Metal catalyzed ones?
Hydrogenation.
Hydrogenation.
Very nice. So one is hydrogenation. So usually you use either nickel or platinum or palladium catalyst. Similarly, just like hydrogenation, you also have a lot of decomposition of gases. So that takes place by using a catalyst. Okay. So thermal decomposition of ammonia. So NH3, 2NH3 gives N2 plus H2. This takes place on catalyst, I think platinum catalyst only. I'll just have to refer quickly. Yeah, platinum catalyst at a very high temperatures, 1130 Kelvin. And then we've got decomposition of nitrous oxide, laughing gas. So 2N2O gives N2N2 plus O2. So these are all examples of zero order reactions. Gas, gaseous state. Okay, so this also occurs only on a certain catalyst. This also happens on platinum catalyst. And then you've got decomposition of एक और gold surface पे भी है. Decomposition of HI gas, hydrogen iodide on gold surface. Will not be there. Okay, so these are all like basically decomposition with metal catalyst, or like decomposition that is done over a metal surface. Okay. So can anyone explain why these fall under decomposition, zero order chemical reactions? Like how come it is independent of the concentration, or in this case, the pressure of the reactant?
Ma'am, so it's just like you said, right? The reaction will continue at its own pace, no matter how much concentration of reactants is there. Because like the sites which are there where the reactant is going to go and the reaction is going to take place, if you give enough reactant that all the sites are occupied,
Yes.
more concentration cannot be settled there unless the previous batch has left.
Correct. So no
So
matter,
the reaction will be at a particular pace only, like it can't
absolutely,
exceed that pace.
yes. So no matter how much ever gas you put in, if all of the sites available on the metal surface are occupied, then no matter how much ever gas you put in, the reaction is not going to get any faster. So that's going to be a zero order reaction. So extending on this, answer one question. Are zero order, like if I have, like, let's say I take decomposition of ammonia, is this going to be a universally zero order reaction? Like no matter at how much ever quantity, or how much ever platinum surface I'm going to take, no matter whatever concentration of ammonia gas I'm going to take, is it going to be forever a zero order chemical reaction?
No, ma'am. When you said that no matter how much platinum surface I take, as the surface increases, the binding sites will increase, right? So that will increase the
Yes.
rate of reaction.
Yes. So zero order chemical reactions, technically they are not zero order universally. So at low concentrations, so if I take very low concentration of the reactant, okay, enough that so if I take like extremely low concentration of the reactant, that all of the surface is not filled up. So so increasing the pressure of the gas, or increasing the amount of this particular gas, is going to push this gas towards the available space on the reaction, which means that it basically turns into a first order reaction because it depends on the concentration of ammonia. Okay. So technically the graph for zero order reaction is a straight line until a certain point, after which it is going to have a bit of a turn. Like it's not going to be a straight line, it's going to turn, like it's going to curve off like this at low enough concentrations. The reason is that a lot of zero order reactions you will observe when it is enzyme catalyzed, or that's happening over metal surfaces. And if the concentration of reactant is low enough that you have more of the metal surface available, like increasing the concentration of the reactant, be it pressure of the gas or literally the concentration of a reactant, is going to increase the rate of the reaction. So it's not going to be a perfect straight line till it goes to zero. At low enough concentration, it's gonna like taper off this way. Okay, so that's like a fun fact, or like a note about zero order reactions. So at low concentrations, they will not be zero order. Okay, so zero order chemical reactions, they're not like universally, they're not going to be zero order. Okay, so just a quick revision of the rate equation. So for zero order chemical reaction, the integrated rate equation is going to be concentration of R, the reactant, at time t is given by minus kT plus initial concentration R naught. Okay, and if you were to find the rate constant K, you just rearrange the reaction and then you'll be able to find it. Okay, so just revise it, make a note of it, and we're going to start doing some problems. Okay, you guys ready? Cool. Share. All right, 5 questions. First one, using the integrated form of the rate law, determine the rate constant K of a zero order reaction if the initial concentration of substance A is, so substance A is the reactant. Okay, so initial concentration is 1.5 m, and after 120 seconds, the concentration is 0.75 m. Quickly, this is like a very direct question. You can refer to the formula if you've taken note of it. So देख के 1 minute में solve कर लेना, मिल जाना चाहिए. Yeah, Janine solving. Jasmine has already sent her answer. Yes, Jasleen has also sent it. Both of you are correct. Very good, guys. Rest of you, कर लेना. अभी तक मिल जाना चाहिए answer. You given that it's a zero order reaction. You given, what all are you given? You given the initial concentration. तो क्या होगा वो? Ananya, so on your screen you can see first question. So we're still on the first question itself. Do it. Aryan, check your calculation, man. Not correct. Amala, Rutvik, yes. But units क्या होगा? Ria, check your division. Yeah, Amla, yes, that would be the unit. Decimals का कुछ तो issue है Ria, so check your calculation there. Rutvik, yes. Janine, yes, but what units? So direct apply कर सकते हो. K equal to R naught minus R upon T. That is equal to R naught is given to be 1.5 m minus 0.75 में decrease हुआ upon time is 120 seconds में. So this minus this is going to be 0.75 upon 120. Divide कर लो. 75 by 120 into 10 power minus 2. 25 में तो नहीं जा रहा है. 325s are 340s, 5 5s are 5 8s are, so 5 by 8 कितना होगा? Siddharth, yeah, so if, yeah, number galat hai if you use that. Jinein, yes, units correct. Riya, still not correct. इसको divide कर लो. So 5 by 8 itself is 0. कितना है? 0.625, हाँ, into 10 power minus 2, which means that you should get 6.25 into 10 to the power minus 3. Concentration is in M, which is moles per liter, and time we've taken 120 directly, so seconds. Yeah. So that calculation में कुछ तो issue है. So if you took 2 minutes also, it'll be, you'd get 37.5, ऐसे कुछ मिलेगा. 75 by 2, yeah. Okay. So Arya, I haven't gotten an answer from you. Kingshuk, I haven't called out your name either. Haven't gotten an answer from you. Ananya, yes. 0.6 into 10 power minus 2, but no, your units are wrong. Check your units, Ananya. It won't be seconds. You're not calculating the time. Okay. All right. Okay. So Arya and Kingshuk. Okay. All right.
Ma'am, I got the answer, but I didn't divide it.
You left it as 5 by 8 into 10 power minus 2.
Yes, ma'am.
But
Sorry,
भेजना चाहिए ना? Like at least I would know that you're doing आया कि नहीं आया.
Yes, ma'am.
Cool. Let's do the second one, Abhi. This one, do it slightly faster. Using the substance from previous problem. So yes, like same substance. So you have calculated what is the rate constant, right? Is reaction के लिए. What is the half-life of A if the original concentration is 1.2 m? Okay, this part we have not discussed, right? So I'll quickly discuss half-life also parallelly for zero order and then for first order, so that it goes hand in hand. It is simple. Okay, so half-life का definition ये है कि amount of time taken for R to become half of the initial concentration, right? So let's figure out what is the half-life for a zero order chemical equation. So integrated equation, we know it as R equal to minus KT plus R naught. Okay, so half-life calculate करने के लिए what should R be?
Half R.
Half of R, yes. R naught by 2. So half-life is usually denoted by T half. 1 by 2. Okay. So at T equal to T half, R should be R naught by 2. So let's plug it in this equation to figure out what is the half-life. So R naught by 2 will be equal to minus K T half plus R naught. So on rearranging the equation, can you find out what T half is?
It's gonna be R naught minus R naught by 2 by T half. Sorry, by K. Yeah.
Yes. So if I take this to the other side, I'm gonna get minus R naught by 2. So minus minus cancel karke, I get K T half equal to R naught by 2. And so T half will be R naught by 2K. So if this is too fast, you can just do it step by step. But this is the equation you need to reach finally. Okay. So isse there are two observations. half-life depends on one, it is directly dependent on R naught, which is the initial concentration. And two, it is inversely proportional to the rate constant. Okay. So what does this mean? Directly dependent on initial concentration matlab, the more of a reactant you take, how much time is it going to take for it to reduce to half? Is it going to take more time or less time?
More time.
More time, directly proportional there. And the greater is a rate constant of one reaction, uska half-life will be lesser. So
Lesser,
basically,
yeah.
yeah. And this is pretty intuitive, right? Rate constant zyada hai, matlab rate of reaction is pretty high, which means that reaction jaldi ho raha hai, which means that it's going to take lesser time for the concentration to decrease to half. Yeah, makes sense? All right. Now, based on this, can you just quickly calculate what is the half-life iska? You're given the initial concentration. So what is the half-life? Siddharth, not sure. Check. Rutvik, nahi. Jasleen, yes, got the answer. So use the rate constant from the previous thing, which is basically 0.00625. Yeah, 6.25 into 10 power minus 3. How to get into... अच्छा 10 raised to the power minus 3. Okay, not 103. ठीक है. हाँ तो उसको मल्टीप्लाई कर सकते हो ना जस्मीन. So anyway it is 0.096. So Siddharth and Ritvik, you guys need to check. Aryan, what about this matlab? No, it's not, no, not, your answer is not correct. So that's like practically no time at all. 10 power minus 2 matlab. Yeah. Okay. Do you want to take a look at the working and the formula? I'll just display that correctly. Ritvik, yes, correct. So initial concentration upon 2K. Amala, no, that's like really tiny, like that's a really short amount of time. See, another logical, like Ritvik, yes, now you got it right. Another logical way to figure it out is, first question में क्या हो रहा है? 1.5 m reducing to 7.75 m is basically reducing to half of its this thing, right? So वो हो रहा है 120 seconds में. If you take 1.2 m, which is slightly less than 1.5, directly proportional to rate constant, right? So it should be slightly less than 120 seconds. So your answer should be around 120, could be 110, 105, 100, 95, that's it. Jinan, no problem. Yeah, you're right. Siddharth, you're right. Just put the units. Okay. All right. So T half equal to R naught upon 2K. So R naught in this case is 1.2 m upon 2 into this we estimated to be 6.25 into 10 power minus 3. ऊपर लेके जाओ 1.2 into 10 cube upon 2 into 6.25. 1.25 into 10 cube upon, I just multiply this because it makes it easier. 2 5s are 10, 5, 13.50, yeah, ठीक है.
Ma'am, how
नहीं,
did we get
12.5.
1.25? How did we get 1.25?
259 2 होना चाहिए. Yeah, my bad.
So
नीचे
ma'am,
12.5
instead of like,
Hmm?
can't we just cancel 1.2 by 2 and put 0.6 in top and then cancel it for 0.1 from the denominator?
Can you repeat that? I was not able to follow.
So when you divide 1.2 by 2 in the denominator, you get 0.6 into 10 to the power 3,
Okay.
right?
Hmm.
Yeah,
So
and
you
then you
get
divide 6.25, so you get 0.1 into 10 to the power 3,
So in this case, you're going
close
to
to
get
0.1 into 10 to the power
approximate
3.
value. So the correct answer, because majority of you have gotten it, is 96 seconds. If you are given options like
Okay.
96 second, 100 second, 1 or 2 seconds, you're going to get stuck. So where the variation in options is a lot, yeah, you can use approximate values. You can just cancel it and you get 100 seconds from there. But if you have really close options, then you will have to like do a proper accurate calculation. So yeah, you can use your judgment for that. So if you think approximate value, okay, if you're given 96 seconds, 36 seconds, 120 seconds ऐसे, तो it's a clear cut, okay, 100 के पास जो भी है, that's the right option. But if you are given close by options, or if this was a question you got in your board exam, better to have an accurate calculation. Yeah. Cool. All right. Kingshuk and Arya, I still haven't gotten answers from you guys yet, man. बाकी सब लोगों ने भेज दिया. All right. So question number 3. If the original concentration is reduced to 1 m in the previous problem, so basically 1.2 से 1 m हुआ, does the half-life decrease, increase, or stay the same? So basically,
It
instead
should
of
decrease,
1.2
right?
at 1. Yes.
Yeah.
Nice. Cool. So if the half-life changes, then what is the new half-life? Wow. Array. So Jasmine and Ritvik have calculated, but बहुत ही अलग-अलग answers आए. I think Ritvik's is closer. Arya, no, I just got like, this is literally the first message I got from you that you're typing the answer. अभी जो 348 को भेजा, that I got. Jasmine, calculate again. Ananya, you also will have to calculate. Arya, maybe you're sending it to somebody else in the meet, because even if you send it to everyone, usually आता है मुझे, and send it to host भी आता है, so either ways should work. Siddharth, yes, that makes sense, correct. See, 1.5 से 1.2 जब हुआ तो 120 से 96 हुआ, so 1.2 से 1 m हुआ तो how much should it reduce to? Should be close to like 96 से it decreased by 20 something, right? So another less than that, it should be close to 80, 85. Yeah. Jasmine got it, like she got a shortcut. How? Yes. Amala 10 seconds नहीं होगा. See, 120 से 96 हुआ, 96 से 10 तक तो नहीं जाएगा ना. So that should like raise a red flag in your head कि इतना ज़्यादा difference कैसे आ सकता है. ठीक है. Kingshuk, yes. Answer is correct. Awesome. Okay. So the answer to this is 80 seconds. Again, exact same formula. Just be careful with your calculation, guys, because I can see that you're taking the formula correctly, but answers काफी different are. Okay. Yeah, 80 seconds is correct. Cool. All right. Question number 4. Given are the rate constants K of 3 different reactions. So reaction A का इतना है, reaction B का इतना है, reaction C का इतना है. Which of these represents a zero order reaction? Okay, so this -1 should be in the superscript. It is mole per liter inverse second inverse. This is mole per liter second inverse, like mole per liter per second, and this is just second inverse. So तीनों में से which one is a zero order
Reaction D.
reaction?
Reaction
Very
D.
nice. Cool. So this was based on what we had discussed yesterday, right? Units of the rate constant. Okay. Question number 5, true or false? If the rate of a zero order reaction is plotted as a function of time, the graph is a straight line where rate is equal to k. So read the question carefully. Is it true or false? I'm gonna let you guys answer before discussing this. Ritvik has sent the answer. Nice, that was fast. Good stuff, Ritvik. Aryan has also sent the answer. Nice, good stuff. Jasleen has also sent. Amala has also sent. Jasmine has also sent. So that, what is A? Are you taking A true, B false? कहाँ से आया A? Riya has also sent. So, if you see, you're plotting rate of a zero order as a function of time. ठीक है? So one variable is rate. So rate will be equal to zero order के लिए what is the expression?
KT plus R naught.
Hey,
Minus
rate
KT plus
equal
R naught.
to
Oh, right, sorry.
rate is equal to क्या है इधर? Ritvik also KT plus R naught. Don't blindly say like memorize it. You're looking at the rate of the reaction, not concentration of reactant. So rate is equal to K into Ananya is saying equal to minus dr by dt, which is correct. Minus dr by dt will be equal to zero order के लिए क्या होगा? Is it dependent on any concentration of the reactant? No. So it's just going to be K. Concentration का power is 0. So ये बन जाएगा 1. So K into 1 is just K. So this is the equation, right? So basically, rate is equal to K, the rate constant K. So obviously this is going to be correct. This part is true. If it is plotted as a function of time, what is the graph going to look like? As time passes, what will happen to the rate? What's this
It'll
graph?
stay constant, like parallel to the time axis.
Yes. So rate is independent of time. dr by dt, okay, concentration of the reactant is changing with time, but essentially rate is equal to the rate constant. So rate is constant, it is independent of time. So of course the graph is going to be a straight line where the rate ka value, whatever value this is equal to, is going to be equal to k, because rate is equal to k. So this is of the form y equal to the constant wala graph. ठीक है? ठीक है. Majority of you have answered true. So how did you figure it out, you guys? So Amla had said false.
It was
Get it?
pretty straightforward, man.
Yeah. No, but it was a little confusing because abhi tak you were working with concentration of reactant and suddenly you're asked about rate as a function of time. So that is why I wanted to do this. Okay, so read carefully.
Ma'am,
Yeah.
we've done this in math essentially, right? Because speaking of rate, saying rate as a function of time is essentially just a rephrasing of it. So, and since we've done functions, it didn't. Yeah, it was not a challenge.
Yeah, that's cool. That's awesome. All right. So this is all about zero order reactions. We discussed about half-life, and we also figured out how to calculate the rate constants with respect, like given the initial final concentration of the reactants. Okay. Now moving on to first order reactants. All right. So we're going to do the same exercise for first order reactions also. All right. So let's start off with the rate law for the first order reactions. Okay, so first order में how do you express rate of a reaction as? Rate is equal to, which is basically minus dr by dt. Again, like what do you call it? Hypothetical reaction we are considering is reactant giving product. So this will be equal to, what is the rate law? Any of you, should I call out names? Ananya, what will be the rate law for a first order reaction? Hello, Ananya, are you there? Yes, Jasmine has answered. All right, so it's going to be equal to K into the concentration of the reactant. Yes. And guys, always put concentration in square brackets. Ananya and Ria, you guys. I understand where it's not easily typable, but you have square brackets on your keyboard, so you should be able to type this. Okay. Okay. So this raised to the power 1 overall, so that makes it a first order reaction. Okay. So again, let's do the same exercise. Let's take all of the same variables onto one side. So this is going to be dr by r, concentration of r is equal to minus k into dt. Then integrating on both sides, you get. So what is integral of dr by r?
1.
Huh? Aryan, I think you're muted. Math people should be able to say this, like, you know, it should be at the tip of your fingers, because this year 70% is just differentiation integration. So if you don't recall integration immediately, think of it like reverse engineer it. क्या किसको differentiate करने पे you're going to get 1 by r. So that, yes, correct, you're right. So
Ma'am, shouldn't
Is it
that
going to be log of r?
will it be log or ln?
Log to the base e, yeah, so
Yeah.
that will be log. Yeah.
Yeah. ठीक है.
ma'am, isn't that K into R naught?
अभी तक R naught नहीं like this is the rate of the first order reaction. So how it
Okay.
varies with respect to time is like it's dependent on concentration of R raised to the power 1. ठीक है.
Okay.
So अभी तक नहीं आया वहाँ तक. All right. So integral of dr upon r is ln r. So this is ln is basically natural logarithm, log to the base e. ठीक है. So standard notation is if I just write log 2, it means that log to the base 10 2. If I write ln 2, it means that log to the base e ka 2. Okay, so this is like standard notation. Not sure if you have come across this pehle, but I just wanted to just let you guys know. All right. Oh god. Anyway, so integral of minus k dt will be
minus kt
that's it.
plus c, of course, because
Yeah.
integration.
Yes. Okay. So now, how do we find the value of c? We'll have to eliminate one of the variables. Independent variable hai t. So at t equal to 0. So just when you're starting the experiment, दूसरा variable r will be equal to
R0.
r naught, just the initial concentration. So substituting the values. So ln r naught will be equal to minus k into 0 plus c, which means that c, constant of the integration, is going to be equal to ln r naught. So now we have our equation. Okay. Just a moment. So therefore, our integrated rate law is going to change as ln r is equal to minus kt plus ln r naught. So इसको थोड़ा rearrange करने पे, so this is basically your equation. This is what you're going to change. But for the ease of calculation, we'll be looking at different, what do you call it? Like different rearrangements of this equation. Okay. So one is if you want all logarithms to be on one side, like if you know the initial concentration and final concentration, and you want to find either k or t, you can express this as ln of r minus ln r naught equal to minus kt. This I can write it as, so kt will be equal to, ये reverse हो जाएगा and
Ln r0 minus ln r.
Yes. So laws of logarithms are not upon r. So ln r naught minus ln r hoga. And if you know, if you recall the rules of logarithms, log a minus log b will be equal to log a upon b. That's what we've used here. Okay. So this is another format that you can use. If you were to find the rate constant, you can find it out like this. So k, the rate constant, will be equal to 1 by t ln of r naught upon r. Okay. So all of these are basically derivatives from this main equation. So it, like, if you're good at memorizing, you can memorize each of them. But if you're bad at memorization, you can just like remember this one basic thing and you can derive all others from this. Okay. Another way, like this is when you've taken the initial concentration to be 0, like this is one way of looking at it. Another way of looking at it is, let's say you are able to get the concentrations of the reactants at particular time intervals. Okay? Like at T1, you're able to get one concentration of the reactant, like kahan tak pahuncha hai, that will be equal to minus k T1 plus ln r naught. And at T2, again you're able to get and the next this thing. So let's plug both those values in the equation. This is what you get. Okay. So if you don't know the initial concentration, you can still calculate what is the rate constant using this particular equation. Okay. So now you've got two instances. So like at two instances, you got like two different concentrations. So once you subtract both of them, you get ln of R1 upon R2 will be equal to KT2 minus KT1, which means that you can get K is equal to 1 by T2 minus T1 into ln R1 upon R2. Okay. So basically you're able to calculate K irrespective of whether you have the initial concentration or not. Like if you have the initial concentration, then you can check the concentration of the reactant after a certain time t, and you can use that to calculate the rate constant. And it's not necessary, like another way of calculating, like if you don't have the initial concentration, you can still measure the concentration at two different instances, at T1 and at T2, and then you can plug it in this formula and you can still calculate the K. Okay. So basically calculating K is obviously for a particular reaction, it is independent of the initial concentration. The rate constant only depends on the temperature. Okay. So this is one aspect of it. Now, further analysis, let's go back to our initial equation, which is ln R equal to minus KT plus ln R naught. Okay. Now, if I were to plot the graph, like if I compare this with y equal to mx plus c, so what sort of a graph will this form? Again,
It will be a similar graph to the last one.
yeah, so y equal to mx plus c is going to be a straight line. But is it the same as last time though?
No, ma'am, no, ma'am.
So iska slope will be what? Just look at the equation and figure out what will be the slope.
K,
Is it k?
I think. Wait.
Amala got it, Jasmine got it. Jasleen also got it. See, x, the variable is t. So what is multiplied by x? What is multiplied by the variable here? Is it just k or is it something else?
Minus K.
Yeah, slope is going to be minus k. That's important because the minus represents that it is decreasing here. Okay. Then what will the y-intercept be equal to? Acha, before we get the y-intercept, the variation is going to be linear. यहाँ पे y-axis में क्या होगा? क्या लिखूं मैं y-axis में? x-axis is time t, ठीक है, independent variable. ये dependent variable क्या होगा?
The concentration only.
Is it the concentration? So just compare this equation, no, word to word. x की जगह t है, तो m is equal to minus k. Y की जगह क्या है इधर? Ananya has gotten it. Amla has also got it.
Natural log of R.
Yeah. So the variation is linear with respect to ln R, not the concentration itself. Okay. So this is like an important point. So the y-intercept is going to be what? This point?
Ln of R naught.
Ln of the initial concentration, R naught. Yeah. So just note this down, important points. So variation is linear between ln R and time. Yeah. So this is one thing you need to be careful of. So you might get MCQs or stuff like that, or assertion reasoning essay. Maybe you'll be given options for a first order reaction, choose what is the right variation. So one option may have just concentration, the other option may have logarithm of the concentration. So that way you need to be a little careful. Okay. So in this case, in this particular this thing, the slope will be equal to minus k. Okay. Now let's do something else here. Okay, just note this down. Let me know when you're ready. So we'll go to the next aspect. Done? Okay. All right. Yeah, just lean done. Aryan done? Okay. Jinain, I think you're still copying. Okay, also done. All right.
Ma'am, 1 second.
Okay. So note down this graph. This is important. Don't just write it in words, but note down this part. Yeah. Huh. So do you guys know how to convert natural logarithms into log to the base 10? Yes, no? Math
No,
people? No. Didn't this come up in physics at any point of time? Like when you're doing this integration, natural logarithm tha, but log to the base 10 conversion nahi aaya. Okay, so there is like a quick hack conversion. So like the basics are rooted in mathematics. So if you're interested, you can look it up and derive it. But basically, so if you have log to the base e, any number, like let's say a, this is basically equal to 2.303 into log to the base 10 a. So if you want to convert any natural logarithm into logarithm to the base 10, because the log tables that you have or in scientific calculators, you can only calculate with base 10. This is like the multiplying factor. Okay. So you just multiply it by 2.303 and you can convert both of them. So using that, instead of natural logarithms, if we convert it to your base 10, like your regular logarithms. All right. Again, I'm going to use this particular form of the equation. So I can write it as ln R naught upon R equal to KT, right? Which means that 2.303 into log R naught upon R will be equal to KT. So natural logarithm को मैंने regular logarithm में convert किया. Okay. So again, mathematically, once you rearrange it, instead of natural logarithm, you'll get it in terms of regular logarithm. This is the equation that you're going to get. Okay. So log R will be equal to so this will be KT by 2.303 plus minus KT by 2.303 plus log R naught. Okay. So instead of ln R, if I plot a graph between like if I plot a graph between log of R and time. So in this case, again, y equal to mx plus c, like वो सब it's going to be the same, except what will be the slope in this case?
Minus k by 2.303.
Yes. So if I, yes, here. So everything remains the same, just that the constants change, like the numerical values change. So in this case, the slope will be equal to minus k by 2.303. So instead of natural logarithm, if I take log of concentration of R, it is this case. And intercept is also going to change accordingly. So this is going to be log of R naught instead of the natural logarithm. Okay. So the only difference between natural logarithm and log to the base 10 is this factor 2.303. Everything's just going to change by a factor of 2.303. So depending on the mathematical equation, yeah, like divided, multiplied, जो भी है, that way. Okay, so these graphs we have drawn between natural logarithm of the concentration versus time based on the equations that we have, y equal to mx plus c. Now, what if I draw a graph between the concentration and time itself? Time on the y-axis, I'm taking r on the x-axis, time on the x-axis, r on the y-axis for a first order reaction. What's the variation going to look like? Straight line, logarithmic, exponential, कैसे? I'll give you three options. You can...
Is it going to be like a decreasing line only, but with a curve, like something like this?
Choose A, B, or C. कैसे दिखेगा? This is a straight line. This is like U-shaped, and this is like ulta of U ऐसे. Zeroth order, it's a straight linear variation देखा था हमने between R and T. First order के लिए 1 by R, like logarithm है ना? तो is it gonna look like
it will
this?
be the U-shaped one.
Yes, it's gonna look like P. So the decrease is going to be fast when there is a higher concentration of the reactants, and slowly it's going to, like, the decrease is going to get slower and slower. That's what it's gonna look like. So once you guys are done, let's move on to figuring out the half-life. Acha, before we get on to half-lives, where do you usually find first order reactions? So some occurrences, maybe like this, I saw it from your textbook. One is hydrogenation of ethene. So there you usually find first order because it depends on ethene as well as hydrogen gas. Next, others are,
Ma'am,
huh?
but isn't the catalyst in hydrogenation gonna be the same like a metal catalyst?
So yeah, so if it is a catalyzed this thing, then it's going to be zero order because it purely depends on the gases. But in this case, under other conditions, like if you're directly um, reducing ethene, like when you're doing addition reaction of ethene, of hydrogen to ethene.
Oh, okay.
Yeah. So it
Okay,
depends on
got
ethene
it.
as well. It depends on hydrogen as well. And Amla has mentioned radioactive decay. Yes. So the stuff that you guys learned in physics, radioactivity, all of them follow first order kinetics only. Okay. All right. So half-life of first order reactions. Again, let's derive it exact same way. Half-life is basically T half. So at T half, basically your concentration becomes R naught by 2. So let's plug these values in our equation. So ln of R naught by 2 will be equal to minus K T half plus ln of R naught. Okay. So if I get ln R naught over here, and agar minus sign ko if I just want to remove it, just by rearranging, I'll get ln R naught minus ln of R naught by 2 equal to K into T half. What will LHS be equal to? Can you work it out? Just do that mathematics and tell me what should I write in LHS? Ritvik, Janain, Kingshuk, any of you guys this time? What should I write?
So it becomes ln of 2
Ha,
when
yeah.
I
So
mean
ln of 2 will be equal to
ln of 2 is 0.69.
numerical value, yes. So that basically is equal to 0.693. So one interesting thing that you can observe over here is, what is the final expression for KT half? For T half? So
0.693 by K.
yeah. Is it dependent on the initial concentration of the reactant at all?
No, ma'am.
Yes. So an interesting thing is that this first order chemical reactions are independent of the initial concentration, like the half-life of for the first order chemical reactions, and they are inversely proportional to K, just like with the zero order. Okay, but yeah, the main point of contention, point of difference is that in the case of zero order reactions, it is directly depending on initial concentration. So if you double the initial concentration, your half-life also gets doubled. But for first order reaction, it doesn't matter how much of the initial concentration you take, it is going to take the same amount of time to reduce the concentration to half that value. So whether you take 2m HCl or 1m HCl, if you want to reduce 2m to 1m or 1m to 0.5m, it's going to take the same amount of time. That's like a really interesting thing that you can see here. Okay. Now, because, yeah.
Ma'am, just a doubt that popped up in my head.
Yeah.
So you told us that hydrogenation of ethene is one example where the reaction is a first order reaction, right? So in the examination, can they ask us calculate the half-life for hydrogenation of ethene? Can this be a question they can ask?
You're going to get more information on about that. So they'll tell you, like,
Okay,
if it says it is hydrogenation of ethene is done by using a nickel catalyst. So because it's a metal catalyzed, it becomes a zero order. Then you'll be given the initial concentration. Like, you will never get a question where it's just says ki calculate the half-life for this. You'll be given a little more information. Yeah. Okay. All right. Okay. So one thing is that half-life for first order chemical reaction is independent of initial concentration, right? So sometimes it so happens that it is preferable to like, you would want a particular reaction to follow first order kinetics, because all it depends is on K, and K is independent of everything except the temperature, like except the temperature, and it's like a pure property of that particular chemical reaction. The only way you can change the rate constant is by manipulating the temperature. So it doesn't depend on, like, first order chemical reactions does not depend on initial concentration of the reactants. So think of it from the context of like industrial production of something. So depending on demand supply, yes, industries try to like keep the quantity of substance they're producing constant, but of course due to demand supply of the raw materials, there might be some variation. Like, there's going to be seasons where there is extreme production, there's going to be seasons where where the production is less. But all your processes and things, like, because reaction is not the only thing when you're manufacturing paint or dye or something like sugar or something like that. Along with the chemical reaction producing that substance, you also have other processes that are lined up, like, putting it in the boxes, putting in the tubes, and you don't want buildup of a gas in any particular process, because then there's risk of it exploding and all of that, right? So it is preferable that if you have the process that is independent of the concentration, that's like one less thing for you to worry about, because it's going to take the same amount of time no matter, like, okay, it's going to reduce to half. So some reactions, if you manipulate the reaction condition such that it automatically becomes a first order reaction, like especially when you have, let's say, second order reactions. Now this is something you observe in hydrolysis of esters. So we're going to be looking at this reaction also when we do the chapter on carboxylic acid and esters and all of that, aldehydes, ketones, that particular chapter. But yeah, so hydrolysis of esters. So let's say you have an ester, CH3CO, CH2CH3. When you hydrolyze it, it's basically the reverse process of esterification, right? In an acidic medium, you get your acid back and alcohol back. So this reaction is a second order reaction. It depends on the ester as well as water. But water is basically a medium, right? Like you can provide any amount of water basically. So the way, like, sometimes how you do this reaction is you take excess of water. When you take excess of the solvent, it doesn't matter even if there's like a tiny change in in the concentration of water, in the quantity of water.
So
Like,
it becomes a pseudo first order reaction.
yeah. So basically, originally it's a second order reaction, which means that rate basically depends on K into the concentration of ester as well as the concentration of water. But when concentration of water is like really large, the change in concentration of water is almost negligible. So this is basically equal to minus d ester by dt, which is also equal to minus d water by dt. So this basically becomes irrelevant when this is very small as compared to the change in the quantity of ester. So essentially this basically follows first order kinetics only when one of the reactants is in excess. So these kind of reactions are called pseudo first order reactions. Okay, so in simple words, pseudo first order reactions are the reactions which are originally, in reality, they are not first order reactions. They may be second order reactions, but you manipulate the reaction conditions. For example, taking one of them in excess such that um, it starts following a first order kinetics. Yeah. All right. So let me know when you guys are ready to do problems based on first order reactions, and then we'll get to it. Okay, Ria is done. Jaslene's done. Okay. Ananya is also done. Cool. So that's done. Should I display the equation part of the screen? I'm assuming Kingshuk's also done, unless you have a doubt.
No doubt, ma'am.
Okay, so you're done. All right. Are you noting this down, or should I display the reactions wala page so that you can get a quick revision in?
Done, ma'am.
Okay, Arya
Done,
is
ma'am.
also done. Ritvik's done. All right, Janine, Arya, and Siddharth also said done. Okay. All right, Janine and Arya, stop me if you guys are still noting it down. Otherwise, I'm going to go to the questions.
Yes, ma'am, noted.
Okay. First order. Okay. Okay. So can you guys see this page here? So example 14.5.1. This is like an external textbook that I found. It's got like good problems, good explanation. Okay. All right. So at high temperatures, ethyl chloride produces HCl and ethylene by the following reaction. So basically elimination, dehydrohalogenation ho raha hai. Using the rate data for the reaction at 650 degrees Celsius presented in this table, calculate the reaction order with respect to concentration of ethyl chloride and determine the rate constant. Okay, so you're given 4 iterations of the experiment. So you're given the initial concentration in M, so that's like moles per liter, and you're given the rate of the reaction, initial rate of reaction. When the concentration is so much, the rate was calculated to be so much. Okay. Now, what are you asked to find?
Ma'am, first we are asked to get the order of the reaction.
Yes. So once you get the order, then you can determine the rate constant. So how are you going to get the order of the reaction?
No, it can be seen by observation that as you're increasing the concentration, the initial rate of the reaction is also increasing.
Yes, but to get the order,
So,
you need to figure out how is that dependency. Like, is it like, okay, if it
yes,
is,
ma'am. So,
yeah,
rate of the reaction is directly, proportional to the concentration of the
directly
reactant.
proportional, okay, but is it directly proportional to C or is it directly proportional to C square, C cube? क्या मिल रहा है इधर? That is what you need to observe. That's what you need to calculate and find out. So order वही है ना? So order is, so if you have rate equal to K into concentration of the reaction raised to the power X, you need to find what is X over there. So this is going to give you what the order is. अगर X 0 है, constant है, तो that's 0 order. But you need to figure out X 1, 2, like how. Okay. Are you guys solving? Any clue or do you want me to discuss it?
No, I don't have any clue.
Okay. Discuss. ठीक है. So how you figure it out is, again, you have experimental data. What did I say yesterday? So you've got rate, you've got your concentration. अगर x है तो rate का कुछ तो value निकला y. If you double the concentration, check what is the rate you're getting. So if I were to compare this, the simplest one is look at experiment 2 and experiment 3. यहाँ
So
पे
Y is also doubling up.
हाँ, I'm doubling this. So y is also doubling. Y is also becoming 2y. So what is the dependency like? If I'm
X is
making this 4
X
times, this is becoming,
4 times.
this is also,
X is 1.
yes. So what is the order of this particular reaction?
First order.
First order, yes. If in case, like hypothetically, okay, not in this particular case, if I double the concentration and the rate becomes 4 times, then what can you say the rate of, like the order of the reaction is?
Second order, ma'am.
तभी वो second order होगा, right? So that is how you need to figure, that is how you can analyze it. That's how you can figure out the order of the reaction when you're given this sort of a problem. Okay, awesome. So order मिल गया, first order. You have the some data also, concentration and rate K. Can you figure out what is the rate constant? Formula क्या है? Rate constant is equal to, or rather than that, you're given the rate and concentration. So what formula are you going to use which involves the rate, the concentration of the reactant and rate constant? तीनों इन्वॉल्व होके कौन सा फॉर्मूला है अभी? Riya is already solving it, I think. Amala, what's up? Jasleen, yes. You got the right one. Jasmine, लेकिन if you use the differential rate equation, हाँ, you can basically use that. Yes, you also got it. Ritvik, Kingshuk, Jinane, Siddharth, were you guys able to figure out which formula to use? What equation do you know of that has these three variables? Your silence is frightening, you guys. Siddharth, Arya, Jinane. Do you guys get an idea कौन सा equation use करना है? Yes, Ritvik, what equation are you using here? Jasleen, yes. So when you're using scientific notation, do it in a proper way. So don't leave it as 160 into, convert it to 1.6 वैसे. Okay. Ritvik, yeah, I kind of expected you guys might be going in that direction. So if you were to use the integrated this thing, तुम्हारे पास time का कोई information नहीं है ना? So these are the only three informations you're given. You know the rate, you know the concentration at a particular time, like, and this is what you need to find out. Ananya has also gotten it. Good, nice, very good. Jasmine also got it. Okay. So Ritvik, what formula do you have that does not involve time? Like if you have rate, concentration of reactant and rate constant, इन तीनों को involve करके कौन सा equation है तुम्हारे पास first order के लिए? Yeah, absolutely. That is what you are supposed to use. So first order rate law क्या है? Rate is equal to K into the concentration of the reactant. So यहाँ पे एक ही rate नहीं, you've got like 4 different cases of rate. You can use any one of them. और उसका corresponding concentration भी you're given. 4 different cases. Right? So using this equation, you have 2 known. You can find out the single unknown. Yeah, Siddharth, awesome. Calculate करके बता देना what your final answer is. So I'm gonna pick the third one at random. Okay. So rate in the third iteration is 4.8 into 10 raised to the power minus 8 is equal to K, we don't know, that's what we are supposed to calculate, into concentration of the reactant at that point is R. Okay. So concentration of this one we already have. R kya hai? Let's put the value there. That's 0.030. So K find out करने के लिए just divide both of these. You should get. Amla, check your calculation na. Again. So your K will be equal to 4.8 into 10 power minus 8 divided by 0.03. into 10, 0.3 into 48 will be 160. So you should get the rate constant K as 1.6 into 10 raised to power minus 6 second inverse. Awesome. All right. Jocelyn, we'll just be doing problems abhi. So yeah, you can watch the recordings and then keep doing the problems later. Or else what I'll do is I can compile these problems. It's gonna take some time, but I can compile these and I can send it to you guys. You can practice it any time.
Ma'am, can you repeat this? The whole thing that you just did, the
Yeah, sure.
calculation, like what?
I'll do that. I'm just gonna take a fresh one. All right. So we already know that the order of the reaction is first order. Okay. Now we need to find out what is the rate constant K. ये find out करने के लिए what all information do you already have? I'll need you guys to participate here. What is given to you?
Ma'am, the concentration and the initial rate of the reaction.
You're given the concentration and you're given the rate of the reaction for that particular concentration. And you have to find out K. Now, you don't have any information about time. So these are the only things you have. What equation do you know of that involves these three quantities? The concentration, rate, and rate constant.
I know dr is k dt, but that has t in it.
But no, you've got minus dr by dt equal to k into r. First order here, so be careful about that. So what is this quantity minus dr by dt?
That's the rate of the reaction. Yeah.
Yes. So now Amala and Anya have gotten it. So rate is equal to K into concentration. So you know what is the rate? You know what is the concentration? You have to find out K. So now we have got like
Okay,
four
ma'am.
options.
Okay,
You can
ma'am.
use any of these to figure it out. Yes.
Okay, ma'am.
Awesome. Jinin, Kingshak, you guys got it?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. Good. Yeah. So go on to the next problem then. Yeah. So 1.6 into 10 power minus 6 second inverse. Okay. Okay. Sulfuryl chloride, SO2Cl2, thionyl chloride decomposes to SO2 and Cl2 in this reaction. So the data for the reaction at 320 degrees Celsius, constant temperature, it's given. Again, 4 iterations of the experiment and varying concentrations, how the rate varies. Calculate the reaction order with regard to sulfuryl chloride and determine the rate constant. So again, it's the exact same problem as the previous one.
Ma'am, again it's
The
one.
different
Sorry,
ones.
first order.
Okay.
First order.
Yeah, as you're doubling, ये भी double हो रहा है. So, ठीक है. First order. Now, quickly calculate the rate constant. So you're given the same pattern as the last one. So this you guys should be able to do. फटाफट भेज देना अभी. Aryan has already sent in, so I'll see. Yes, Ananya also. Aryan, just check your exponents, huh? कुछ तो issue है. Check the calculation. Ananya, right answer. Do not forget units, Ananya. Siddharth, yes. Good stuff. Got it. Correct. Riya, check your calculation. Galat hai answer. Just see that you have used the correct values, huh? If you take rate 1.10, concentration, take it as this first one only. By mistake, if you take 0.1, फिर गलत हो जाएगा. Okay, so be careful. Aryan, yes, now it is right. Ensure that you take corresponding values. So again, you have to use the same rate equal to K into concentration of reactant. Amala, check calculation, huh? It is exponent में थोड़ा सा गड़बड़ है. It is off by a factor of 2. Jinein, yes, correct. Ritvik, correct. So if I take the easiest one, like if I take the third one, because it is 0.01, आसान होगा. उसका rate है 2.2. So 2.2 into 10 power minus 7 is equal to K into 0.01. 00 ठीक है, लिखना. So K will be equal to 2.2 into 10 power minus 7 divided by 0.01. अगर ये numerator में गया तो it will be into 100. So your answer should be 2.2 into 10 raised to the power minus 5. Okay. So when you're given these kind of problems, no, where you have a set of data and you have to calculate for one of them, pick whichever looks the easiest in calculation. Second and fourth, तो you've got like 165, 275 and all. उसके साथ कौन divide करेगा? Okay. So just see that you use the correct one. Amala, what happened? Did you check?
I'm not getting it.
Oh, क्या किया तुमने? Like what values did you take?
I took the rate as 1.1 into 10
Okay.
raised to minus 7 and the concentration as 0.050
मतलब
and
divide होगा ना?
yes. And I wait.
0.0 नहीं, 0.005 है इधर. तो इसको modify करने
copied it
पे
down wrong.
Divided by 5 into 10 raised to the power minus 3 होगा. So कर लो, should be able to get it. ठीक है. So calculation is one area you need to work on, but otherwise formula concept तो समझ में आ गया. So that is fine. Okay. Arya and Kingshuk, I have not gotten answers from you. Siddharth, Ananya, everybody else has sent it. ठीक है. All right. So next question. We'll do 2 more questions, huh? So it may leak to 5:10, 5:15. Just stay. But I want to finish off this first order ka this thing. All right. If a sample of ethyl chloride initial concentration is given 0.02 hai, heated at 650 degrees Celsius, what is the concentration of ethyl chloride after 10 hours? So over here, you're given the initial concentration. You have to find out 10 hours ke baad what will be the final concentration. Final nahi, like what will be the concentration? How many hours at 650 degrees Celsius, so at same temperature, must elapse for the concentration to decrease to 0.005 m? So you're asked same problem in 2 ways. So basically you have to use the same formula, just that first case में you're given the time, you need to find the final concentration. Second case में you're given the final concentration, you need to find out the time. Rate constant is given at 1.6 into 10 raised to the power minus 6 second inverse. So another thing you guys need to be careful about is here you're given in second inverse, time you're given in hours. So don't take 10 as it is, be careful with your conversions as well. Okay. So before you start, write down what is the given information and tell me what equation you're going to use in this situation. What equation are you going to use? Given initial, so that's R naught. Given time for the first part, given K. And for the second part, you're given the final concentration. Okay. So Ananya, Amala, what the time interval will be? So what will be the time interval for the first part? So you're taking this much ethyl chloride, 10 hours के बाद कितना होगा? So obviously your time is going to be 10 hours. But since rate constant is in second, this you need to convert it into seconds. Okay. So what, Ananya, what equation are you going to use to solve this?
Sure about the equation. I like it has to be one of those ln ones, but because those terms are there, but I'm not sure which equation.
Yes, correct. See, you're given your initial concentration, you're given the time, you're given K, you have to find out what is R at the end of the 10 hours. So you have, like, if you use the integrated rate equation for the first order, you should be able to get it. All right. So before we even get to the equation, how do you confirm that it's a first order equation for the first order reaction? अभी हम practice कर रहे हैं तो because we are doing it under first order पता चल रहा है. But if this was a question you got randomly in your exam as it is, how would you know whether to use the zero order reaction equation or the first order equation? Very nice. So Riya has found out. So the hint of the order of reaction is in the unit of K. Okay. So unit of K is in second inverse. So this will have to tell you कि अच्छा this reaction is first order. इसलिए we have to start using all the equations and things related to first order. Okay. So that's one more thing you guys need to take care of. All right. So first order kinetics पता चल गया. These are our required information. This is what we need to find. तो equation क्या होगा? Who remembers the first? So Ananya, if you don't remember which one, you can always refer to your notes until you get the hang of it, until you're able to memorize it. Now, whether you use the ln version of it or log version of it, tell me, how do you do the calculations? Like, are you allowed scientific calculators, or do you have to use your log tables? What do you have to do? You have to use log tables only. Okay, in that case, फिर ln use नहीं कर पाओगे ना, so you'll have to use the logarithm version of it. Okay, so who remembers what the equation is? Log r equal to, याद नहीं किसी को, minus k t by 2.303 plus log r naught. So now plug the values. R naught का value क्या है? R का value, no, this is what we have to find out. We know k, we know t, 2.303 is a number. So just plug the values, calculate and find out. Aryan, are you able to hear me now? Let me also switch off. Okay, so this is gonna be Guys, any update? Abhi ke liye, for the time sake, you can use calculator. Abhi फटाफट calculation करने के लिए. So where have you guys reached? कुछ मिला? Give me an update, no? Like, are you still calculating? या फिर are you stuck somewhere? Or okay, you're still calculating. ठीक है. So were you able to get the value of what is log r? Oh, 20. Array, you took 0.02 m. So that is not going to become 23 m, ना? इससे कम ही होना चाहिए. So log r का वैल्यू कितना मिला? ये पूरा कैलकुलेट करने के बाद कितना मिला? This you should get minus 1.7 something. 1.723 ऐसे कुछ. ये log of 0.02 है. So this you will get in negative value. You won't get 20 something. Check.
No, I got log of 0.02 as minus 1.698.
Minus 1.698 ना. Then
Yes.
ये calculation करने के बाद overall.
Oh, that I did something wrong. Because the value I sent you, that is log r का value.
अच्छा. Log r का value minus 1.72 मिला. This on taking anti-log, like 10 raised to the power this देखना. Once I took anti-log, concentration of r, your final answer you should get 0.0189, like 18888 ऐसे कुछ मिल रहा है, approximated to 0.0189 m से आना चाहिए.
Okay.
Okay. What about the rest of you, Ananya, Janine, Ria, Kingshuk? At least half the calculation, log r कितना मिला, were you able to find out? No? This you guys need to practice, man. क्योंकि first order kinetics के problem सारे logarithm से related ही रहेंगे. It's gonna be like this. Okay. All right, it's already 5:10. Let's jump to the next part of it. How many hours at 650 Celsius must elapse for the concentration to decrease to this much? How will you solve that part? If you have to find out the time, what do you have to do? अच्छा डिस्कस कर लेते हैं ना पहले, like calculate it in a bit. All right, I'm just gonna mention this and we'll end the session after this. Okay, I'll see there's one more problem. If that is something that will happen quickly, we'll do it. If that's also like this, तो फिर बस discuss करके I'll send these problems to you guys. You can work it out, figure it out on your own. Okay. So for the second part, you're given the final concentration कि 0.005 होना चाहिए. So basically log of 0.005 will be equal to minus k, you already know, 1.6 into 10 power minus 6. T is what you have to find out, upon 2.303 plus log r naught, so you already know what is r naught, 0.02. Okay, so once you do this calculation, you get the value of t. Another thing, if it's easier for you guys to work with natural logs, then you don't have to divide by that 2.303 factor. But if your log tables you only have to the base 10, then you will have to divide it. So the answer, I'll share it with you guys. So concentration आना चाहिए 0.0189 and time आना चाहिए 2.4 into 10 square. That's 240 hours. Yeah. Next. Final, so your sulfuryl chloride is first order, calculated the rate constant. So previous question ka hai ye. Use the forms of integrated rate law to find the amount of SO2Cl2 that remains after 20 hours if a sample with original concentration of 0.123 m is heated at that particular temperature. How long would it take for 90% of SO2Cl2 to decompose? So iska format is same as your previous one. You're given time in one case, you have to find the final concentration. And in the second part, you're asked for the time, given that you want 90% to decompose. Matlab, your R will be, so if 90% is decomposed, kitna bacha rahega concentration of R? So what will concentration of R be equal to in this case? If 90% is decomposed. Yes, so 10% will be remaining. So 10% of R naught. So R naught is given, which means that you can easily find out R. So you have to find out the time. You know what is R, you know what is K, you know what is R naught. Plug the values and find what is the time. Okay. All right. So I'll share these problems with you guys, and also